New YouTube video. Today I will be helping you guys learn how to solve and balance chemical equations. This is a method I use in my exams and hopefully it helps you. Let's get started. First of all, I'm going to be telling you about the LHS and RHS of an equation, which you must know already if you're doing IB chemistry, but I will be explaining anyway. This part of the equation on the left side of the arrow is called the LHS of the equation, and this is the RHS, and this is how I will be referring to these in this video. So I hope you understand this side of the equation is the LHS and this side is the RHS. Alright, now let's get started. Let me quickly get rid of this. Let's get started to balance this equation. I have excluded state symbols, which will be covered in another video, and this is balancing with whole numbers and not fractions. Let's get started. The first thing I would advise you to do is always balance the hydrogens, because these are the most tricky ones, which you should get over with first, in my opinion. So let's get started with the the hydrogens. What we can do here is see that there is a subscript of 2. Whenever we do these balancing equations, to find out the number of hydrogen atoms in each part, we multiply the initial coefficient, which is supposed to be the number that is here, but if there's none, we assume it's 1, and the subscript. So for the hydrogen on the RHS, it is actually going to be 1 times 2, which is 2 hydrogens. And on the LHS, it is just 1 times 8, which is 8. To balance this, we need to take the smaller number. What can I change on the smaller number so that I can achieve to the biggest number? Here the answer is simple. 2 times what can give me 8? That answer here is simple. We need 4 more of this water molecule to achieve a balanced state with the hydrogen. So what we're going to do is, let me quickly just remove the small details. We are going to be using a 4 here. We're going to put a placeholder of a 4 because it might be incorrect. We still have to check later. But for right now, we're just going to put this number of hydrogen to be 4 on here. And here, I don't think we really need it because we already balanced regarding the 8. If I put a 2 here, let me try to put a 2. Yeah, if I put a 2 here, this would impact my equation because now we're going to have 2 times 8, which is 16 hydrogen, and then I have to change this again, and that's not what we're supposed to be doing. We're supposed to get the simplest form, so we're going to be using only the 4 over here. Next, let's look at the carbon molecules. Here the carbon molecules have 3, but here the carbon molecules is only 1 because there's only 1, there's no subscript, and only 1. So the answer for this part is pretty simple. Let's just put a placeholder of a 3 in front of the carbon. Now we have 3 carbons on the LHS and RHS both. So we can see the condition is satisfied, this is satisfied, and the hydrogen is satisfied. Now let's look on to the oxygen, which is usually the tricky part of these equations. On the LHS, we have 2 oxygens, but on the right hand side we have 3 times 2, which is 6 oxygen, plus 4 times 1 oxygen, which is 4 oxygen. Oh my god, I think these look like 60s, so I will just erase them. Let's just keep it as 6 plus 4, because otherwise people are going to think it's 40. Let's just keep it to be 6 plus 4. So on the right hand side, we have 10 oxygen. Well, this part is really simple. Take the smaller number, 2 oxygen. What can I do to, I did the O thing again, I'm sorry guys. What can I do to the smaller one to achieve the biggest number? Well, the answer is simple, multiply it by 5. So let's go back into our equation. Let me erase this circle. Oh, my O also went away partially. Let's bring it back in. And now we put the placeholder of a 5. These are all placeholders. I keep saying placeholders because sometimes in these equations, it can actually be quite difficult to see which answer is the right one because of factors, which I will cover in another section right now. I'm just trying to teach you guys how to balance this equation. Alright, if you have any questions, please let me know. But now we're coming on to the checking stage. Always check your equations. Checking is really, really important. Otherwise, you might miss the small keys. What I suggest is draw a line down the middle. This is going to be down, which I just use the arrow key or the arrow to separate it, and write down each element you have. So I have a C, an H, and an O. I have a C, H, and an O. The elements that we have. And here I also have a C, H, and an O, so I'm going to write again CHO. Now, we're going to write how many of each element are there. Sorry. I will be writing CH and an O. Here I have 3 oxygen. I have 3 carbon. I'm really sorry. I have 3 carbon, 8 hydrogen, and here 5 times 2, which is 10 oxygen. On the right hand side, I have 3 carbon, 3 times 2, 6 oxygen, plus 4 times 1, 4 oxygen, which is also 10 oxygen, and I have 4 times 2, which is 8. Are these two numbers the same? Is this the same as all of this? That's what we're trying to figure out. And the answer should be yes. My whole work just went away. I'm really sorry, guys. I will write it back down. Yes, we can see that the left-hand side is equal to the right-hand side, and hence we have achieved our final state of balancing this equation. So the final answer for balancing this equation is C3H8 plus 5 of oxygen gives 3 carbon dioxide and 4 water molecules. I hope this video helped you to learn to balance. More challenging ones are coming soon. Thank you.